Hello everyone. Today we will continue to learn the frequency domain analysis module of continuous system. In this lecture, we will discuss the spectral characteristics of singular functions. The main contents include impulse function, impulse couple function, and the unit step function. First, let's look at the impulse function. According to the definition of spectral density function and the screening of impulse function, we can get the spectral density function of impulse function, as shown in Formula 1. Figure A is the time domain waveform of the impulse function. Figure B shows its spectrum characteristics. In fact, delta t can be regarded as the limit of unit rectangular pulse because the bandwidth of unit rectangular pulse is 2 pi over tau. When tau approaches 0, its bandwidth approaches infinite. Because the integral of impulse function is finite, so we can use formula to calculate the spectral density function of the impulse function. This is the same as the calculation of ordinary functions. Let's make a comparison. Impulse function is time domain waveform. Its spectrum. DC signal is time domain waveform and spectrum. By comparison, we can get that the impulse signal has very short duration, but its spectrum occupies the whole frequency domain. Usually, we call it Y spectrum. The duration of DC signal is infinite. Its spectrum has value only when omega equals 0. Let's look at the spectrum characteristics of impulse couple function. According to the screening property of impulse couple and the definition of spectral density function, we can get the frequency spectrum of impulse couple J omega. Finally, let's look at the spectral characteristics of the unit step function. Obviously, unit step function is not absolutely integrable, so we need to make a function. Express delta t as 1 over 2 plus 1 over 2 times sgnt. Because we have obtained the spectrum of DC, 1 over t of the spectrum is pi delta omega. The spectrum of sine function is 1 over j omega. Therefore, the frequency spectrum of unit step signal is shown in Formula 3. Here, you need to know that for unit step function, there is an impulse with intensity pi when omega equals 0. In this section, we mainly discussed the spectral characteristics of the impulse function, spectrum characteristics of impulse couple function, and the spectral characteristics of the unit step function. This class is over. Thanks for your attention. Goodbye.